Hey everybody, this is a quick solution, or relatively quick, to problem 2e from our 1-4, our equation review. You can see the problem on the screen. We're going to work through a solution to that one. I'm hoping that you were comfortable with it. I'm also hoping we were as efficient as we could be, so pay close attention. When you're working through that equation, a common approach would be to sit there and say, okay, well, I have all of these divide-bys, and since I am working on an equation, for me to get rid of my divide-bys, I can just simply multiply both sides by the same thing. Good. If we end up doing that, then we could do a multiplication of every term and choose to multiply to get rid of all of our divide-bys. So to get rid of a divide by x minus 1, we are going to multiply by x minus 1. And then we would do that same thing on each individual term. But why waste your time going through and just getting rid of one denominator? Let's get rid of them all. So I then see that the denominator of my second fraction is an x plus 2. So I'm going to get rid of that divide by x plus 2. To get rid of a divide by x plus 2, I'm going to multiply by x plus 2. So I'm going to put in like another x plus 2 factor that I'm going to multiply everything by. And I know I'm doing this quick, but you know what it says even when it gets messy. Then you take a look, and on the right side of the equal sign, you see another divide by x plus 2. So you like that. You can get rid of that divide by already with that multiplication. And then you take a look at your last denominator, 1 minus x. And so to get rid of a divide by 1 minus x, we can multiply by 1 minus x. And if you chose to multiply everything by 1 minus x, we're actually multiplying by more than what we need. I want you to take a quick peek. Working your way through that is no problem. But if you choose to multiply by that green to everything, I'm just not going to waste my time writing it, you will guarantee that you have simplifying you have to do. Guarantee it. One way to avoid that, one way to avoid all that extra algebra, like you're going to have an extra factor of 1 minus x that you're going to have to expand into all those brackets. You can simplify a different way. So everything that we just did in the blue was great theory. Great theory. I'm just going to get rid of my green brackets because I want to recognize a pattern. When you look at that denominator and you see 1 minus x, I'm hoping we can see that is really close to x minus 1. They're just different signs. So if I factored out a negative from 1 minus x, then I'm left with negative 1 plus x. That's the same thing. Look, it's the same thing. So, if I were you, what would I do to go through and deal with this? I'm just going to go through and erase everything on the last fraction to make sure we're good. My first line would look like this. I see that those two denominators are super close. I can see the extra factor of negative 1 in the last denominator. So, if I factor that denominator, then I can see the only difference between those two denominators is that extra factor of negative 1. So I could, if I wanted to, choose to multiply by negative 1. Or what I could do is to account for that negative 1, I'm instead of going to multiply it on the bottom of my fraction, multiply it on the top of my fraction. Right? I can move that negative across the fraction line. A positive divided by a negative is the same thing as a negative divided by a positive. But by me applying that negative to the top, now I can expand it into the top, which affects that sign. So, if I was to start this problem off, this would be my exact approach. Okay, I'm not going to touch the first one. I'm not going to touch the second one. Whether I recopy that out or not, I need to for good form, but it doesn't affect my theory. My first fraction on the right side isn't touched. But now, everything I just talked about, my denominator is going to be factored by -1. I can then move that -1 up. And so instead of adding a negative, I'm going to subtract. And so I can simplify that last fraction to that. The red is my solution. And why do I like the red? Well, I like the red because now, to get rid of all of my divide bys, I only have to get rid of 2 different divide bys, not the third. So when I choose to multiply everything by x minus 1 times x plus 2, I'm doing the same on the second. If you need to write out all of them, feel free. Write out all of those multiplications. It'll help you to avoid a mistake. But now I'm going to go ahead and deal with the division. Within that first fraction, I can now divide out my x minus 1. And so all I need to do now is simplify x plus 2 times 2x minus 3. I'm not going to keep writing in all those purple circles. I'm just going to do my division. Divide it out. Divide it out. And now divide it out. And so if I need to, I could write this line down. I'm going to do it in green because I don't need to see it. The x plus 2 times the 2x minus 3. My denominator is gone. The x minus 1 times x minus 1, so I'm going to square it. The x minus 1 times a 2x minus 5. And an x plus 2, oops, I forgot my subtraction. And I need to subtract my x plus 2 times my 2 minus x. And there we go. For a lot of us, we're going to be able to look at that big, ugly red with purple line and simply expand. You could work your way through now and say, okay, well then there is my 2x squared minus 3 plus 4 minus 6 minus, I think we should be good to be able to expand that perfect square and subtract every term. Subtract your x squared. Expand your brackets, you're going to get a minus 2x, subtract it, so it's a plus 2x. You're going to get a plus 1, subtract it. Same thing on the right side. Just slowly and methodically work your way through expanding all your brackets. On the next one, okay, I should be able to see that I'm going to get a negative x squared in there, so subtract it. When I expand, I'm going to get a negative 2x and a positive 2x, so those are going to cancel out. And I'm going to end up getting a positive 4, subtract it. Okay, worthwhile to on each line, collect. I would strongly suggest putting this line in. I think it allows you to avoid some risk for mistake. Now that we do that, sorry, I'm just going to look back up into my green line. I just noticed that almost looks like a 7. I want to fix it. It was a minus 1. So now I can go through. My leading term is positive on the right. So now I'm going to end up standard form, divide out your common factor. And we love the fact that that thing factors. So x minus 4 times x minus 1, and therefore x equals 4 or 1. Okay, so a really sloppy solution as I just kind of jot down that end stuff. Now, one of the look-fors that we have to be very conscious of when we go through and we solve an equation, and I'm just going to shrink that back to, ooh, it's not all moving for me, but I'm going to shrink that back down a little bit just so we can get back to the beginning, what the original equation looked like. One of the look-fors we need anytime we have variables on our denominator is, could those solutions that we just found be unacceptable? That is, if I take a look back up to my original, I'm fine to sub in 4 everywhere and be able to calculate everything. But you should notice that when you sub 1 back in, and I'm just going to circle up here in green in my original, either my x minus 1 or my 1 minus x, then I'm going to get a 0 in that denominator, and now I'm dividing by 0, I'm going to get an undefined value. So we need to make sure then that when we solve for that 1, or any solutions, we check back, and any solutions that we get that we could not accept, we have to make sure that we have to label as inadmissible. So write the inadmissible right under the 1, draw an arrow to the 1, I do not care. We can accept the 4. The 4 is the solution to that equation. 1 we cannot. Okay, there you go. I'm hoping that helps you through your practice. Best of luck with the rest.